Alright, so today we're diving into resistors, those essential components in almost every electric circuit. Resistors are the unsung heroes that manage current flow, ensuring circuits function safely and efficiently. Whether you're a budding engineer or just curious about electricity, understanding resistors is key. What is a resistor? A resistor is a device designed to provide a specific resistance in an electric circuit. Resistance controls the flow of electric current, much like a narrow pipe restricts water flow. In real world circuits, resistors are often small cylinders with colored bands indicating their resistance value. But in circuit diagrams, we simplify them with the zigzag symbol. Practical note: in circuit analysis, we assume that connecting wires have no resistance. Wires like copper or aluminum are excellent conductors, so this allows us to focus entirely on the resistors for calculations. Here's an example problem. A resistor in a circuit has a resistance of 100 ohms, and a 9-volt battery is connected. What's the current flowing through the circuit? Using Ohm's law, current equals voltage divided by resistance. Substituting the values, 9 volts divided by 100 ohms equals 0.09 amperes, so the current is 0.09 amps. Types of resistor configurations. Electric circuits often combine resistors, and their arrangement matters. Let's explore the two common configurations: series and parallel. In a series configuration, resistors are arranged one after another along a single path for current. The total resistance is simply the sum of all individual resistances. For example, if you connect a 10 ohm resistor and a 20 ohm resistor in series, the total resistance is 30 ohms. In a parallel configuration, resistors provide alternative paths for current to flow. The total resistance is calculated using this formula: 1 divided by the total resistance equals the sum of the reciprocals of the individual resistances. For just two resistors, we can simplify this to the product over sum rule. For example, a 6 ohm and a 12 ohm resistor in parallel would have a total resistance of 4 ohms. Notice that the total resistance in a parallel combination is always less than the smallest resistor. Here's another example. Find the total resistance of a circuit with a 15 ohm and a 30 ohm resistor in parallel. Using the formula, total resistance equals the product of the resistances divided by their sum. Substituting the values, 15 times 30 divided by 15 plus 30 equals 10 ohms. So the total resistance is 10 ohms. Mixed configurations. Many real-world circuits combine both series and parallel resistors. To analyze these, simplify step by step, combining resistors in series or parallel until you're left with a single equivalent resistor. Let's solve this example. Two resistors, 10 ohms each, are in parallel. Their equivalent resistance is 10 times 10 divided by 10 plus 10, which equals 5 ohms. This 5 ohm equivalent is then in series with another 15 ohm resistor. Adding these gives a total resistance of 20 ohms. Key insights on resistors. Let's summarize some key insights. In a series configuration, the total resistance increases, and the current is the same through all resistors. In a parallel configuration, the total resistance decreases, and the voltage across each resistor is the same. These principles help in designing circuits with precise control over current and voltage. Here's a practice problem. A circuit has 3 resistors, a 4 ohm, and 8 ohm in parallel, and a 10 ohm in series with the parallel combination. What's the total resistance? First, calculate the parallel combination. 4 times 8 divided by 4 plus 8 equals 2.67 ohms. Then add the 10 ohm resistor in series. 2.67 plus 10 equals approximately 12.67 ohms. The total resistance is about 12.67 ohms. Practical applications of resistors. Resistors aren't just theoretical, they have countless applications. Voltage dividers use resistors to split voltage across components. Resistors protect LEDs and other sensitive components by controlling current. And sensing devices, like thermistors, change resistance with temperature to enable temperature sensors. Here's a real-life challenge. You're designing a circuit where a 9-volt battery powers a 3 ohm resistor and a 6 ohm resistor in series. What's the current? First, calculate the total resistance. 3 plus 6 equals 9 ohms. Then, calculate the current. 9 volts divided by 9 ohms equals 1 ampere. The current is 1 ampere. And that's everything you need to know about resistors. From simple configurations to complex circuits, resistors are crucial in controlling current and voltage. To dive deeper into science concepts, visit kotc.me. See you there.